So here's section 6.4, which is a continuation of the elimination method, but this is going to be a little bit harder than last time. Because as you'll see, unlike last time, when you get your problems, you will not have opposites ready to go for you to add downwards so that something eliminates. But the difference here is we just have to multiply first to get opposite coefficients so that when we add downwards, one of the variables will eliminate each other. So let's look at the first example, number 1. Solve each system of linear equations by elimination. So again, we have to solve using elimination. So remember, the first step in elimination is to always get everything lined up. So that's what we already have. We already have the x's on top of each other, the y's are on top of each other, the equal signs are on top of each other, and the constant terms are on top of each other. But if you notice, we have 6 and 2, which are not opposites, and 5 and 3, which are not opposites. But again, all we have to do is use multiplication to make opposites. So let's look at what's going to be the easiest. If you look here, 2 goes into 6. So I could multiply 2 by something to make it the opposite of 6 so that when I add downwards, they will cancel each other. 3 doesn't go into 5, so it will be a little bit harder to make opposites between the 5y and the 3y to make them eliminate. So again, it's not impossible to make opposite coefficients for the y's. It just will be a little bit more work. So again, always choose what's going to be the easiest. So again, if I have a 6 and a 2, I could multiply the 2 times -3 to make opposites. But if I multiply the 2 times the -3, I also have to multiply everything else in the equation by the -3, so including the 3y and the 5. So what I'm going to do is put parentheses around that second equation to remind myself I have to distribute the -3 to the entire equation. So -3 times 2x is -6x, -3 times 3y is -9y, and -3 times 5 is -15. What a lot of kids do is they forget to multiply the number after the equal sign by that number out in front. So I'm just going to rewrite the first equation so I can see the two equations together more clearly. And so now, if you notice, we have opposite coefficients with the x's, so I'm ready to add downwards. Once I have made opposite coefficients, I'm ready to add downwards. So the x's are going to eliminate. -9y plus 5y is -4y, and -15 plus 19 is 4. So we had the x's canceled, leaving us with just the y's, so y equals -1. So now I just take what y is equal to, and I have the option of plugging it back into our first original equation, our second equation, or I could even plug it back into the equation I got after I multiplied by -3. I always just choose the one with like the smallest numbers or the one that looks less complicated. So I'm going to put the -1 in for the y in the second equation just because the 2x plus 3y equals 5 just looks a little bit more simple. So I have 2x plus 3 times -1 equals 5. So 2x minus 3, since 3 times -1 is -3. If I add 3 to both sides, I get 2x equals 8. Divide both sides by 2, and I end up with x equals 4. So remember, I'm still going to answer these as if I graphed them. So the place where these two equations would intersect would be at 4, -1, and that would be my final answer. Let's move on to another example to get some more practice at this. So here's example number 2. Solve each system of linear equations by elimination. 4x plus 5y equals 35, and 2y equals 3x minus 9. So if you see here, our first step in elimination is still to get everything lined up. And again, what you see here is that the second equation is not lined up with the 4x plus 5y equals 35. So what I'm going to first do is subtract the 3x so that it goes from the right side to the left side. And I want the x first, just like in the first equation. So when I rewrite it, I want it as 3x plus 2y equals -9. So again, I'm just going to rewrite my first equation just so I can see the two equations together more clearly. So let's see our coefficients. So I have -3 and 4. Those are not opposites. And I have 2 and 5, and those aren't opposites. Last time we saw that the 2 went into 6, so we chose the 6 and the 2 to make opposites with. But that's not the case here. Since 3 is smaller than 4, I'm going to look at the 3 and think about if I could multiply 3 times something simply to get the opposite of 4, but I can't. 3 doesn't go into 4. Same thing with the 2 and a 5. The 2 does not go into the 5. So in this case, I'm going to have to multiply both equations by a number as opposed to in the last example where I was able to just multiply 1. So let's just choose one of the variables. So let's choose the 4 and the -3. So what I do is I just find the least common multiple between them. So the smallest number that both of these numbers will go into is 12. So 4 times 3 is 12. When in doubt, you can just always multiply them. So what I'm going to do is make one of them a positive 12 and one of them a negative 12 so that I have those opposite coefficients, then I can add downwards. Since the 3 is already negative, I'm going to go ahead and multiply it by 4 to make it the negative 12, which means I will multiply the second equation by 3 to make that a positive 12. So remember, I have to distribute through the entire equation in both examples. So I'm going to write it off to the side here. So 4 times negative 3x is negative 12x. 4 times 2 is 8, so it would be 8y. And 4 times negative 9 would be negative 36. Then I'm going to take the 3 times the 4, which is 12x. 3 times 5y is 15y. And 3 times 35 would be 105. So now I'll take my two new equations and I'm ready to add downward. So these x's are going to cancel. 8y plus 15y is 23y. And negative 36 plus 105 is 69. So when I divide both sides by 23, I end up with y equals 3. But remember, that's not where we stop. We still have to find x. I have lots of options to plug the y back into. I can plug it back into my two original equations. I could plug it back into the equation I got after I moved the 3x, or I can move it into both of these that I got after I multiplied to make opposites. Again, just do whatever's the easiest. Let's just put it back into the first equation, just for simplicity's sake. So I would have 4x plus 5 times 3, since I now know that y is equal to 3, equals 35. So I have 4x plus 15 equals 35. I would subtract 15 from both sides, so I end up with 4x equals 20. And I would divide both sides by 4, so x equals 5. So my final answer, remember, I will write as if I graphed it, so my answer would be 5, 3. So we saw in example 1 where we just had to multiply one equation to make opposites. Then we saw in example 2 where we had to multiply both equations to make opposites. So let's see what example 3 brings us. Again, we're just asked to solve the system by elimination. So we have 6x minus 2y equals 1, and negative 2x equals negative 3y minus 5. So again, our first step is to get everything lined up. So I'm going to add the 3y over so that I get everything lined up. So I'd have negative 2x plus 3y equals negative 5, and then I'll just recopy the top equation so that I can see the two equations working together more easily. So let's see what's going to be the easiest. I see that 2 goes into 6, so it would probably be easier to make opposites between the negative 2 and the 6. The 2 doesn't go into the 3, so I'm going to choose to eliminate the x's first. Since I have a positive 6 down here, I'm going to make this a negative 6 up there by multiplying by 3. Remember, I got to multiply everything by 3 to do that, so I'd end up with negative 6x plus 9y equals negative 15. Don't forget about that number after the equal sign. Now that I've made opposites, I'm ready to add downwards, and the x's will, of course, cancel. Negative 2y plus 9y is 7y, and 1 plus negative 15 is negative 14. So my first answer would be y equals negative 2. Take that answer, plug it back into whatever equation you want. Let's just plug it back into the top equation. So we would have 6x minus 2 times negative 2 equals 1. Negative 2 times negative 2 is 4. So then I would subtract 4 from both sides and end up with 6x equals negative 3. Divide both sides by 6. And so I end up with a fraction, but it'd just be, in lowest terms, negative 1/2. So my final answer would be negative 1/2, comma, negative 2. So here, I would definitely not want to use the graphing method because it would be hard to precisely estimate that the two lines intersected at negative 1/2 and at negative 2 since we got the fraction. And example number 4, our last one. Solve each system of linear equations by elimination. So we have 3x minus 7y equals 5 and 9y equals 5x plus 5. So again, not everything is lined up, so that'll be our first step. I'm going to move this 5x from the right to the left, and I'm going to put it in front of the y since that's what the first equation is in order of. So negative 5x plus 9y equals 5, and I'll just recopy the first equation so I can see the two equations better together. So let's look at now the smaller number compared to the bigger numbers. 3 doesn't go into 5 and 7 doesn't go into 9. So in this case, I'm going to have to multiply both equations to make opposites. So remember, all you have to do is find the least common multiple between the two coefficients. So the smallest number that both numbers will go into. The smallest number that 3 and 5 will go into is 15, and the smallest number that 7 and 9 will go into is 63. So I'm going to choose the 15 just to make our numbers a little bit smaller. Since the negative 5 is already negative, I'm going to choose to make that the negative 15. So I'm just going to multiply the first equation by 3, again, to make that a negative 15, which means I'll make our second equation the positive 15, so I'll multiply by positive 5. So remember to distribute to the entire equation. 3 times negative 5x would be negative 15x. 3 times 9y is 27y. And 3 times 5 is 15. Second equation, I multiply by 5, so I'd get 15x minus 35y, and it equals 25. So now that I've made opposite coefficients, I'm ready to add downwards. So of course, these are going to cancel. 27 plus negative 35 would be negative 8y, and 15 plus 25 is 40. So if we divide both sides by negative 8, I end up with y equals negative 5. Take that answer, plug it back into any equation you want. You have your original two equations, you have the one that you got after you moved the 5x over, and you also have the two new ones you got after you multiplied to make opposites. It'll probably be easiest just to take this and plug it back into the first equation for simplicity's sake. So we would take 3x minus 7 times negative 5, set it equal to 5. Negative 7 times negative 5 is positive 35. If we subtract the 35 from both sides, I would end up with 3x equals negative 30. Divide both sides by 3, so you end up with x equals negative 10. So remember, write your answer as an ordered pair as if you graphed it. So we'd end up with negative 10, negative 5 as our final answer. That's it for this section. We'll for sure go over this in class and show you a few more examples before we move on. But as always, jot down anything you don't understand so we can cover it in class before we move on. And we'll see you then.